So we're buffer problems more practice. This is what the quiz was, what we just completed. Right? So today we are going to switch the question a little bit, and we're going to have the pH be a specific number. So how much you want the buffer to be this certain pH. Just how much strong acid or strong base is needed for that to happen. So again, mole table if you like it, but we're going to be essentially doing the same thing. So I saved myself the trouble of drawing structures because I really am bad at that. And I just scanned it or took a picture of it. Okay, so calculate how many milliliters of 2.45 molar potassium hydroxide or 1.18 molar HCl must be added to 3.85 grams of pyridine to adjust the pH to 4.85. Okay. So which one is it going to be in the first place? If you have pyridine, Shelby, are we going to be adding KOH or HCl to it? What would it be? HCl. Does everybody agree? Because it's got to be the conjugate base. So that means you have to be adding HCl. So that's the one we're going to be doing. This one. Okay? So we know we're going to be using the Henderson or the revised Henderson-Hasselbalch while we're doing as moles. Okay. What could we probably do next, Brandy? What could we probably do next? Do you have an idea? Plug in. Oh, good. Plug in what we know for the pH. In fact, we know the pKa too. Right? That's good.
Acid or base again?
Oh, because Shelby, how did you know you had to add HCl? Because it has, yeah. This is Shelby's way. She says, oh, it has an H plus on it, so that means it has to be a base. That's her way of figuring it out. My way of figuring it out is, I look at the little plus sign, I guess, but it's the same thing. You have to, because the name always corresponds to the which form? The neutral form. The table always corresponds to the acid form. The table always has the acid form, but some of them, they're not all neutral. Like this one, it's not neutral. So the conjugate acid of pyridine has a charge on it. So that means the neutral form must be the conjugate base. Okay. So let's go, just follow Brandy's suggestion here. This is 4.85. pKa 5.2. Okay. What do we put in for the rest of this stuff? Yeah? Yeah. We need to convert those grams of pyridine into moles. And we convert those grams of pyridine into moles. Will that be the moles of the conjugate acid or the conjugate base? Moles of the conjugate base, because that's what Shelby said, right? Pyridine is the conjugate base. So we calculate the moles of this stuff, it'll be the conjugate base. All right, so we'll get that number. Now what is the chemical formula for pyridine? It's going to be this entire structure minus what? Minus the H, right? So you've got, what, 1, 2, so you got an H in each one of these, right? 1, 2, 3, 4, 5 H's. How many carbons? I should keep track of this stuff. Pyridine. 5 H's, 5 carbons, and nitrogen. That's pyridine. Ooh, man, she's fast. 7911. Okay, where am I? 3.8, this is right up here. 3.85 grams. And then Victoria, you said it was 79.11 grams in a mole. And that is 3.85 divided by 79.11. About 0.049 or so, 0.0487. Carry a lot of digits. Your life is safer that way. Okay. Now we said that was the moles of the conjugate base. Let's try it without writing a mole table. See if you like it better this way. That's the moles of the conjugate base. Well, as we add this HCl, minus X or plus X on the top? It's minus X. This conjugate base is going to be reacting with it. So it has to be minus X. And initially there isn't any conjugate acid because it's pyridine. Pyridine is just the conjugate base. So initially there isn't any conjugate acid. There isn't any HA. So any HA that's there is formed, which is going to be X. Okay. So if you like it better without a mole table, great. Otherwise, you probably have to write something like this. Right? And that goes to, right, conjugate acid, do your ice table, and you get the same thing. You get the same result. Eustacio, do you see what I'm doing? Or do you want me to write out the mole table? Okay, let's write it out. I need more space. So, you know what? We don't even need to write this, though. We could write it out our abbreviated way. Right? We know that pyridine is the conjugate base. Right? So pyridine would be my A minus. Initially, I had 0.0487 and nothing else. And then I'm going to do a change here. Right? So I'll have 0.0487 minus X and X. So these are the two I'm interested in. I'm interested in the moles of conjugate base and the moles of conjugate acid, and that's what I'll put in up there. Okay. So I think if this is new to you, this is really a good idea to do. It helps you from getting lost and making silly mistakes. Now we just solve for our X and get our X and realize that our X will be the moles of H+. So when we're all said and done and we solve for X, we can use this to convert to milliliters. Right? So you could do this. Solve for X, right? And then convert X to milliliters of HCl. Try it. Okay? Try it. If I lost you along the way here, just ask so I can help you out. What's that? Is what negative? Oh, you're talking about this X right here? Yeah, technically that's why the term ice table really doesn't make a whole lot of sense, I don't think. Because you're right, that should technically be negative. Going to our little ice table. Ka. 5.2 is the, yeah, in the table, I didn't scan the whole thing. It's pKa, is that table? Okay. Yeah, that table's pKa. Nope. Today? I don't know. If you have questions, I can help you out after class. Oh, well. It's a tennis day. But tomorrow morning, tomorrow I'll be here all bloody day. 8 a.m. through probably 5 o'clock. I have to work like a regular Joe, Javier, tomorrow. It's horrible. But I'll try to, well, what can you do? Just take a close look at your reports that you got back and make sure you don't make the same mistake twice, if you did make a mistake.
Yeah, so like what kind of percentage off would be like an ideal heuristic?
For the lab report, you have to pretty much nail it. You have to pretty much nail it to get 0. So some people actually nailed it. Did you? Not very many people did. That should be a little award. It should be. 'Cause that's tough. So you got a point off? Yeah. Yeah, you have to nail it. Probably. If I had to write your unknown number, yes. Otherwise, I based it? Did you get an answer for x? Do you want me to solve for x? Okay. So you take 4.85 minus 5.2. Yeah? Daisy wanted me to write this. That's good. Negative. People are so demanding, aren't they, Daisy? Negative 0.35 equals the log of that stuff. Raise it to the 10 power. Well, you have to raise both sides to the 10 power. Here you have to raise both sides to the 10 power. So the log just 10 to the log cancels out, the inverse functions. So go on to the next one if you got it done, because I think this is your homework, this handout C. Should you get 0.69? Did you make it 0.69 for x? Really? Oh, let's write 0.03. That's got to be right. See, there's advantages to being the teacher. Do you have more digits than 3?
Yeah, 3.
All right, there. Now that's got to be moles of H plus. Go back to your, right? That has to be moles of H plus. So convert that to milliliters.
So you times that by the 1.18?
Well, you have to actually divide by the molarity. Because flip the molarity, it's get liters on top.
And then times by 1,000.
And then convert it to milliliters. Yep. about 28.5 milliliters.
See that minus there?
Okay. Okay. So make sure you can get 28.5 before you go on to question 2. So that's good enough, right? Yeah.
So that is just a regular X right there, 0.0336.
So now you have this. So you have to add x to both sides. So now you have 1.4468x equals that. And then divide both sides by 1.4668, and you'll have x equals, right? Because you have to add x to both sides. Because you have the number times x. Here you have a negative x. So add 1x to here, 1x over here.
Oh, so you don't just randomly drop it?
Oh, no, no, no. You can't drop anything. Nope. No, no dropping x's. Don't drop any x's in this.
So now when you're doing the base here,
This phenylacetic acid, yeah, it's the acid form.
you're going to do the base.
So you have to be adding NaOH. Or sorry, you have to be adding KOH. That's right. Shelby, I'll be here for a while because I have to set up lab for tomorrow. But I don't know how long that's going to take.
So if the neutral form doesn't have a plus, then it's
Yeah, so this is neutral. So that means this is the name.
so it means this much.
Yeah. If you're not sure about something, I'm glad to help. I think you would have aced it. I think you would have aced it because I think this is really, really close. Yeah, you didn't get your average and then put it up here. Otherwise, you would have had 100%.
So you understand how to solve this. And this X is what gives you your conjugate acid and your acid.
X is the moles of H plus. X is the amount that it changed by, right? Because you're saying that the conjugate base, it reacted with the moles of H plus and it made the conjugate acid. So this is both the amount of conjugate acid that's formed, but it's also the amount of acid that you added in the first place. Because it's 1-to-1 mole ratio.
Okay.
So
that's if
X-
you knew to go with the HCl.
We knew to go with HCl because all we had is conjugate base. All this is conjugate base. So if you add anything, all you can do is add acid. So it has to be this one. And you're going to reduce that conjugate base. So that's why you have to subtract. So that X is going to be the moles of that you added of HCl. So you just have to convert those moles of HCl into milliliters.
Okay. So you knew then that your pyridine was your base form. That's
You-
what we're discussing.
That yeah, you have to figure that out first. Otherwise, you can't even start.
Okay, so since this is a base,
That's a conjugate base.
conjugate
Yeah.
base, you already knew that you weren't going to do anything.
This K, which has nothing to do with anything.
Okay.
Wasted
That's what
space.
Okay, so I think I have an idea now. So now on the next one, I know that that's a phenolacetic acid. I know that's going to be a weak acid.
Yeah.
So that means I'm going to go with my 2.5.
Yep.
pH.
Yeah.
I'm not going to do.
Nope. So you can either go by the name in this case because it says acid,
Yeah,
right?
that's
Or
pretty good.
you look at the structure,
Okay.
and the structure has no plus on it. So this is the neutral form. It's in the table, so it has to be the acid form.
Okay, that makes sense.
So it's healthier not to go by the name. It's healthier to go by the table because then you're always going to get the right answer. But you're right. Whenever it says acid, it'll be
Now, this
acid.
one, this is pepperdine
Hydrochloride. So that one,
I'm betting that that's a base.
yeah, I bet that'd be a good bet.
Oh, and it has a plus.
Yeah.
So now I'll know since that's a base.
In fact, it's hydrochloride. That's the only point of the Cl minus being there, is it has to have a plus on it. But you have to include it in the molar mass.
Okay.
You have to include that hydrochloride in the molar mass.
I'll know that this one's a base, so I know now.
So when you get the molar mass of this, realize there's a Cl negative on this to make it a salt. Otherwise, your molar mass will be wrong.
The structure has a plus sign. I'm gonna use the acid.
Anytime the structure has a plus sign, that means the name only can't be this. The name is only for the neutral forms because it's in a bottle. So you have to remove an H plus. Well, if you remove an H plus, that means this must be the acid form. Remove an H plus, all you have left is the base. The base is neutral. Well, the base will only interact with HCl. But you're right. Whenever you have a plus, it's got to be. It's going to react with HCl.
I'm using the base. I'm gonna instead of like here was minus X, this is gonna be plus X.
Yes. And your number is going to be where?
One. This one.
This. You have to convert this into moles.
Mhm.
That moles is going to go on the top or the bottom in your Henderson-Hasselbalch equation.
Will go on the bottom.
Has to go on the bottom because that's the moles of the acid. So it'll be that number minus X divided by it, and then X on top.
How do you get this number? Because
You have to convert it into moles.
no, but for the first one. It was,
For the first one,
Yeah.
so you have to look at your structure, and it's just that.
Which is 79.
So you have to count up 1, 2, 3, 4, 5 carbons, 5 hydrogens, and 1 N.
Okay, and it's 79.
Yeah. And then so 3.85 grams divided by 79.
Okay.
And then you got to do the same thing for this one. And this one you have to include all of it. All right? Which one is that? It's question 2. Question 2 is, that's up on top. Yeah. So you have to, right there it is right there, figure out how many carbons and hydrogens and everything there are to get its molar mass. Bless you.
Can I actually see the first structure for question number 1? If I'm able to.
This will be visible online, right?
Yeah, it's being recorded right now.
I just wanted to make sure, is that right for number 2?
Number 2. Oh, it's not that. Did you write it down?
No. I'm sorry.
Well, I think I can. Okay, I can bring it back down. So for question 2, it'll be same formula. But on top, you're going to have X. On the bottom, you're going to have some number minus X, right? For this one. All right? And how do you get that number? Figure out what the structure is. C what? 1, 2, 6, C8?
Yes, C8.
H. Yeah, it would be. It would be 8. Yeah, I was counting it wrong. C8H8O2. Yeah, thank you. You're right. So this is, if you're not sure, that's where I would write that mole table. Otherwise, you're going to mess up. So what do we have all at the beginning? Do we have HA or A minus all at the beginning? Well, no, at the beginning, what do we have? What form? The conjugate acid or the conjugate base? The acid. So that means, so I would write it. So it can only react with hydroxide, right? And that's going to form my conjugate base and water. So then you can put your, and then you can do your little ice table to help you out. So that number would have to go here. We have nothing initially. Minus x. Right? So that x.
That's the formula you use when you charge your acids?
Yeah, this is the general formula you're going to, this is what's going to happen when you add an acid. When you have an acid, you have to add a base. That's right.
We don't add more acid bases. We used the round side, not the sharp side.
We'll have to go find it. I'm not sure where it is.
And so we're going to do more review on Friday.
Mm-hmm.
And then test on Monday. Good luck. I know you only got 2 more shots. Right? Instrumental, you don't do moles?
Wait, you don't do moles in instrumental?
Oh, we make solutions. We make solutions in instrumental.
No, I mean, to earn,
We don't do ice tables.
to earn the mole.
Oh, there's no exams. How you can't earn a mole if there's isn't an exam?
One more chance. I know. I'm like, I've been in chem and now.
Wait, pecan.
Correction
Do you get
for
moles
this
in
one?
pecan?
What's that?
Can we make corrections for this? This is what I would like
No,
to-
only the first exam, only the first lab you get to do corrections. Yeah, just have to ask, I guess.
I've already taken pecan and even. They don't give us moles in our pecan. Damn them. I knew Jen was going to be my best bet.
Labs are, because if I were you, if I was sitting in your spot, there's no way I'd go to the last lab. I mean, that'd be ridiculous. See, the Gen Chem people haven't figured that out. No, you tell them that up front. Everybody goes, remember your freshman? You did everything. Didn't matter. But mathematically, everybody can skip that last Gen Chem lab.
We can't skip any last three.
Advanced class. I are. All of you guys are treated the same. Well, you're not in Gen Chem.
You know, in hindsight, I haven't taken this class. I really think we should just have 3 semesters.
It's all the same. Call it analytical Gen Chem. It's all the same. Because you're starting out with a conjugate acid. Yeah. You're starting with the conjugate acid. Yeah, you're starting with conjugate acid. So here's your initial, maybe this number minus x. That's conjugate acid. Conjugate acid on the bottom. Pretty much is just this thing flipped. I don't know. 12.1. 0.9 they're saying.